solve an inequality modulus of twice x plus 3 less than 8. We know that if if c is greater than 0 and mod of x is less than c, then we can write this as we can solve this modulus sign, that is minus c less than x less than c. We can also prove this inequality. Prove. So given c greater than 0 and mod of x less than c, and we want to show that minus c less than x less than c. So case first, if x is greater than 0. Now if x is greater than 0, we know that the modulus function, I am writing here modulus function, okay, mod of x is equal to x if x is greater than 0, equal to 0 if x is equal to 0, and equal to minus x if x is less than 0. So if x is greater than 0, implies mod of x is equal to x. Now since mod of x is less than c, it is given, implies x is less than c, since the value of mod of x is what? X. So say this is equation number 1. Again, now since x greater than 0 implies minus x is less than 0, but what is given? 0, c is greater than 0. So c is greater than 0. So from this minus x less than 0 and 0 less than c, so from this we can write minus x less than c. Okay, from this we can write, if you multiply by minus c, then x greater than minus c. So if you combine these 1 and 2, what one says? X less than c, and from 2 x greater than minus c. So if you combine 1 and 2, from 1 and 2 we can write c less than minus c less than x less than c. Inequality 2 says x is greater than minus c. Now this is for if x is greater than 0. Now if x less than 0, case number 2, if mod of x is if x is less than 0, by using definition of modulus function, if mod of x is less than 0, then we multiply x by minus sign. So this implies mod of x is equal to minus x. Now since given mod of x is less than c, implies minus x is less than c. Now if you multiply by minus sign, then x greater than minus c. Say this is equation number 1. Again, now since x less than 0 and 0 less than c, or c greater than 0, so if you combine these two inequality, we get x less than 0 less than c. This implies x less than c. Say this is equation number 2. So from 1 and 2 we can write, we can say that minus c less than x less than c. So by using case number 1 and 2, we can say that if c is greater than 0 and mod of x is less than c, then minus c less than or equal to x less than x less than c. This is also true if this is also true for c greater than or equal to 0, or c greater than 0 and mod of x is less than c. Then solution of this equation is what? Minus c less than or equal to x less than or equal to c. So And now we are going to apply this inequality to solve this equation, this property to solve this equation. So we want to solve the modulus of twice x plus 3 less than 8. Now what the last property says, if c greater than 0 and mod of x is less than c, then we can solve this modulus sign as minus c less than x less than c. Now here this is the value of c and 8 is greater than 0. From this we can write this as minus 8 less than twice x plus 3 less than 8. Now again, if a less than b, then a plus c less than b plus c for any real number c, or if a greater than b, then a plus or minus c, a plus or minus c is greater than or equal to b plus or minus c. So if we add subtract 3 from both the side, we get minus 8 minus 3 less than twice x plus 3 minus 3 less than 8 minus 3. So this 3 will get cancelled here, and minus 8 minus 3 is equal to minus 11, okay, less than twice x less than 8 minus 3 is what, 5. So again there is one property, if a greater than b and if c is greater than 0, order properties, then ac greater than bc. Now multiply by 1 by 2, and since 1 by 2 is greater than 0, so if a greater than b and if c is greater than 0, then ac is greater than bc. By using this property we can say that minus 11 by 2 less than twice x by 2 less than 5 by 2. So if you simplify this, we get minus 11 by 2 less than x less than 5 by 2. So this is the solution of the given in absolute value inequality, minus 11 by 2 less than x less than 5 by 2. Okay, so hope you understood.